How many milliliters of a 0.5 molar solution of HBr is needed for a reaction that requires 32.5 grams of HBr? Now, this is a molarity problem, and molarity equals moles of solute divided by the volume of solution. So let's analyze this problem and see what information we have to work with. Given the molarity, 0.5 molar solution, so molarity is given, also given 32.5 grams of HBr, 32.5 grams HBr, which is the mass, and our unknown, how many milliliters of solution, so that's volume, which is unknown, and in milliliters. Alright, and so that's our unknown. What information are we going to need? What's required? Well, I know that this grams I can convert to moles, and that's I need that because I have molarity and I'm given grams. I need to find moles of solute if I want to ever get to volume. So I'm going to need moles of solute, which is basically moles of HBr. I'll just call that 8 to HBr. 8 moles of HBr. And also I want my answer to be in milliliters, so I know I'm going to have to do some conversion after that. And so my plan, and here's what the plan is going to look like. First thing that I'm going to do is I'm going to get those moles. I'm going to convert grams to moles first, and so that way I'll have this part of my equation, my moles of solute, and then when I have that, I'm going to go ahead and plug that in, plug in my molarity. So I'm going to plug the information into the equation to isolate the unknown. So once I plug in that, my molarity, which is 0.5, and I plug in my moles of solute, I'll be able to solve for volume doing some basic algebra. And then once I get that volume, then I'm going to convert liters to milliliters. So not milliliters to liters, but I'm going to convert liters to milliliters. Liters to milliliters. That's going to be my third step moving forward. So let's go ahead and do the first one. Step 1, converting grams to moles. And this is fairly straightforward. I'm going to need the molar mass, so that's required to do this. Molar mass of NaOH, no, not NaOH, this is the HBr problem, HBr, and that's going to be fairly straightforward. So looking on my periodic table, H is 1 and Br is 79.9, so that's 79.9, add them up, 79.9 plus 1 is going to be 80.9. Alright, there we go. So 80.9, this is my molar mass of HBr. Great, now I can convert grams to moles. So let's take this 32.5 grams HBr, set it up by putting it over 1 times, and now I'm going to set up my conversion factor. I have grams in the numerator. I want it to cancel, so I'm going to put grams in the denominator from my molar mass. 80.9 grams HBr and 1 mole up top HBr. and the grams cancels, and now I'm going to multiply across. 32 times 1, it's going to be 32 mole HBr over, now 1 times 80.9, it's going to be 80.9, and once that goes in the calculator, 32 divided by 80.9, I get 0.395 moles of HBr. So now I have converted from grams to moles, and now I'm ready to move on to my second step, which is step 2 in my plan. And step 2 in my plan was to plug in the given information into the equation in order to isolate the unknown variable. So just as a refresher, I'll go back and pull up the equation. Molarity equals moles divided by volume, and molarity was given to us 0.5, and that is equal to moles, which I just found, 0.395, divided by volume. This is what I don't know. Volume of solution. There we go. And now I'm just going to do some algebra to isolate this volume of solution. So let's first get it out of the denominator by multiplying both sides by volume times volume. There we go. Volume of solution cancels over here. 0.395 equals volume times 0.5, and now to isolate this volume, get it by itself, divide both sides by 0.5, and that over there cancels. So volume of solution equals 0.395 divided by 0.5. So I'm going to take this, I'm going to divide by 0.5, and what I get is 0.791 liters. This is in liters. And now I'm going to do my third step, because I'm not done yet. My unknown was the volume in milliliters. So now my third step is going to be to convert liters to milliliters. Little m to go. There we go. That's my third step. So probably could do this one in your head, but for those of you who are having trouble remembering that, 1 liter equals 1,000 milliliters. And therefore, if I have 0.791 liters, let's set that up over 1 times, and then I'm going to have 1 mole. No, not 1 mole. I want liters to cancel. The liters must cancel, therefore I have to put it in the denominator over here. Let's put 1 liter down here in the denominator, 1,000 milliliters up top, and now liters cancels. There we go. 0.791 times 1,000 is 791. 0.791 times 1,000 equals 791. And that is our final answer, 791 milliliters of solution. And this is our final answer, so let's go ahead and box that.